Okay, Antioch Bears, next up with quadratic functions and the process of solving them, we got completing the square. The important thing to remember about completing the square is that your c value needs to be something very specific. It needs to be half of the b value raised to the second power. As long as your c value is equal to half of the b value raised to the second power, this process will work. So I've kind of started one here. When I look at this question, it looks like a trinomial, so I start factoring. And I get my x and my x to make x squared, and then I think of my set of numbers that multiply to make 10, which are only 1 and 10 and 2 and 5. And according to the back sign, they're supposed to subtract to make 6, but neither do. So this is one that cannot be factored. In this situation, I go to process number 3, called completing the square. I'm going to rewrite the equation down here. In order for completing the square to work, I need my c value to be half of my b value raised to the second power. What does that mean? Again, b this time is 6. I need to divide it by 2 and then square it. What is 6 divided by 2? It's 3. And what is 3 to the second power? It's 9. I need my c value to be a positive 9. So I'm going to say that again. Half of the b value, so 6 divided by 2, raised to the second power, is what I need my c value to be. I need that to say plus 9. If it doesn't say plus 9, I need to get rid of it. So I'm going to get rid of that negative 10 with a plus 10. That's going to give me x squared plus 6x, and then I'm going to leave a blank spot here equal to 0 plus 10, which is 10. Now I'm going to replace my c value with that specific number that I wanted it to be. Half of b raised to the second power. Half of 6 is 3, 3 squared is 9, so I need my c value to be plus 9. That's totally legal as long as I remember that in an equation, anything you do to one side, you must do to the other. You can add 4 million if you want to. As long as you do it to both sides, you're not doing anything illegal. But we wanted it to be 9, so I've added 9. Just got to do it to both sides. Now the process of doing this has created something called a perfect square trinomial. Okay? I'll write that here. That means that it can be factored, and when we factor it, we're going to end up with the exact same binomial twice. X and x, two numbers that multiply to make 9, but add to make 6. Well, my factors that make 9 are 1 and 9, and 3 and 3, and it's 3 and 3 that add to make 6. With my back sign being a plus, my two signs have to be the same. This time they'll both be positive. Notice that when we factored x squared plus 6x plus 9, we got x plus 3 times x plus 3. That's what makes it a perfect square trinomial. It created the same binomial twice when we multiplied it. Or factored, excuse me. Over here on the right-hand side, 10 plus 9, 19. Now because it's the same binomial twice, I can rewrite it. Instead of having two separate x plus 3's, I'm going to make one x plus 3 and say it is squared. That means the exact same thing that this line means. Anything times itself is really just to the second power. Now I know how to get rid of squares on quantities from the square root method. I just have to take the square root of both sides. And that's going to give me x plus 3 is equal to a positive and negative square root of 19. I'll grab my calculator here. I'm not sure how well you can see it, but it's about 4.4. Okay, 4.4. Now I need to get rid of my plus 3 with a minus 3. And I'm going to get two separate answers for x here, because the first one I got to do positive 4.4 minus 3, and then negative 4.4 minus 3. So positive 4.4 minus 3 is going to give me 1.4. Negative 4.4 minus 3 will give me negative 7.4. Those are my two solutions from completing the square. I have a second one here, and it's a little bit more complex because we have a leading coefficient, but not quite as scary as when we're doing it on factoring, because sometimes those factoring ones can take a long time. But to complete the square, your a value cannot be something besides positive 1. It can't be anything else. If you have a leading coefficient, you need to get rid of it by dividing everything by that number. So everything's going to get divided by 2. That's going to give me x squared minus, I'm going to go ahead and write it in even though I don't have to, 1x. and then plus 9.5 equal to 0. Now, to complete the square, I need my c value to be half of my b value raised to the second power. Well, half of 1 is 1/2, or 0.5. 0.5 to the second power is not 9.5. 0.5 to the second power is 0.25. So I need to get rid of that c value and replace it with the one I want. I can get rid of 9.5 by subtracting it. Now I'm going to replace my c value with the specific one I want. I want half of my b value, remember half of 1 is really just 0.5, to the second power, so 0.25. I need this to say plus 0.25. And if I do that to one side, you got to do it to the other. Now when I have a perfect square trinomial, I can rewrite it as a quantity squared, and I've got x minus 0.5 squared. It's always going to be half of whatever your b value is. Just like up here it was half of 6 or 3. Half of 1 is 0.5. Negative 9.5 plus 0.25 gives me negative 9.25. Now I need to take the square root of both sides, and I get x minus 0.5 equal to, and right here I'm going to pause because I've got a problem. I cannot possibly take the square root of a negative number. If I try that on my calculator, it says nope, error. You can never take the square root of a negative number. So when this happens, when you're solving, your answer is no solution. That means in the world of a quadratic function, it's the type of parabola that doesn't hit the x-axis at all. It will never hit it.